In this video segment, we're going to be using the fundamental identities to simplify expressions. If you missed the video on fundamental identities, go back one and make sure you're comfortable with the reciprocal functions, quotient functions, and Pythagorean functions. Now, let's take a look at our first expression. An expression is a mathematical statement that does not contain an equal sign. For example, secant theta cotangent theta is an expression. We'd like to simplify this expression using the fundamental identities. The identity we'll use in this example is the reciprocal identity to rewrite cosecant as 1 over cosine, and quotient to write cotangent as cosine over sine. To simplify this expression, we need to reduce and again apply our reciprocal identity, since 1 over sine theta is equal to cosecant theta. And we have simplified the expression secant theta cotangent theta down to cosecant theta, an equivalent expression. Let's try another example. The next expression that we'll simplify is secant theta minus cosine theta. To simplify this expression, we're again going to use our reciprocal identity on secant. And then we need to pull out the first of our strategies. One of the strategies we're going to be using in this objective is to get a common denominator. We need a common denominator in order to simplify this expression. Give cosine a denominator of 1 and multiply both numerator and denominator by cosine. This gives us the new expression 1 over cosine theta minus cosine squared theta over cosine theta. Now that the denominators are common, we can rewrite this as a single fraction. And we're ready to utilize another strategy. In an expression with squared values, we want to consider the possibility of using a Pythagorean identity. So the next strategy we're introduced is Pythagorean identities. Which Pythagorean identity involves 1 and cosine squared? The correct identity is sine squared plus cosine squared equals 1. Rewrite this identity so that it's the same as the portion of our expression we are trying to simplify. In this case, we'd like it to say 1 minus cosine squared, so we will subtract cosine squared to both sides. This gives us sine squared theta is equal to 1 minus cosine squared theta. Well, if these are equivalent, that means I can replace the 1 minus cosine squared theta in my expression with sine squared theta, which is exactly what I'm going to do. My expression now says sine squared theta over cosine theta. When simplifying an expression, it's hard to determine when the expression is considered fully simplified. At this point, this expression is considered more simple than the original because it contains only one term instead of two. However, you may be tempted to continue expanding the expression by rewriting it as sine theta times sine theta over cosine. This is a third strategy that we're going to be utilizing in this objective, and that's to split the fraction. In this case, we could actually say that the expression is the same as sine theta tan theta, which some may say is even more simple than sine squared theta over cosine theta. For the purposes of our class, either of these answers would be accepted, since both of these answers represent one term when our expression originally began with 2. Let's take a look at our next example. The next expression we'd like to simplify is 1 plus tangent theta squared. And really for this example, I want to make sure that you're familiar enough with distributive property and multiplying polynomial expressions in order to use those skills in trigonometry. To rewrite this, we would put 1 plus tangent theta times 1 plus tangent theta, and then we'd actually need to multiply this. Now the amount of scratch work you show when distributing out a product of binomials is going to depend on your own familiarity with multiplying binomials. As we get to the end, we find that this expression is equivalent to 1 plus 2 tan theta plus tan squared theta. At this point, we want to see, are there any ways that I could simplify this expression further? Going back to the strategies we've seen so far, the one that stands out is possibly the use of a Pythagorean identity. Because I see a tan squared, I'm curious to know if there's a Pythagorean identity I can use to substitute out these values. And as it turns out, there is. We have an identity that states tan squared theta plus 1 is equal to secant squared theta. So we're going to replace the 1 plus tangent squared theta with its equivalent secant squared theta. From here, we want to utilize our primary strategy in this objective, and that's to convert everything to sine and cosine. This is going to be the fundamental strategy in fundamental identities. For this expression, I can turn secant squared theta into 1 over cosine squared theta, which is a reciprocal identity, and I can turn tan theta into 2 sine theta over cosine theta. From here, I can try to get a common denominator. By multiplying cosine theta to the right-hand expression. And I get 1 plus 2 sine theta cosine theta over cosine squared theta. At this point, using only the identities that we're familiar with, there's not really much else we can do with this problem. And so I'm going to look back through my scratch work. Every line in this problem is an equivalent expression. 1 plus tan theta squared is the same as 1 plus tan theta times 1 plus tan theta. Is the same as this, is the same as this, is the same as this. And I want to look for what I consider to be the simplest form of this expression. And I'm going to say that the simplest form was probably back here when I still had secant squared theta plus 2 tan theta. Let's take a look at 2 more examples, both involving fractions, to make sure we have the necessary fraction skills to get through simplifying trig with identities. For this next example, we're going to take a look at a pretty simple fraction. We have secant theta over tan theta. Utilizing our main strategy, which is to rewrite everything in terms of sine and cosine, we're going to rewrite this expression to be 1 over cosine theta over sine theta over cosine theta. Here I've used a reciprocal identity and a quotient identity. How do you simplify a fraction that looks like this? Well, we know that fraction division is the same as multiplying by its reciprocal. From here, I can simplify the cosine theta, and I get 1 over sine theta, which leaves me with a final answer of cosecant theta. Secant theta divided by tan theta is equivalent to cosecant theta. For our last example in this video, we're going to take a look at a slightly more complicated fraction. The last example we're going to look at in this segment is cotangent theta plus tan theta over secant theta plus or times cosecant theta. Starting with our first strategy, we're going to revert everything in this expression to sine and cosine. Cotangent is cosine divided by sine. Tangent is sine divided by cosine. Secant is 1 over cosine. And cosecant is 1 over sine. Here, we need to pull out a few more strategies. For example, I can find a common denominator in my numerator. To make these denominators the same, I need to multiply each fraction by the opposite. So over here, I'm going to multiply a cosine theta. Over here, I'm going to multiply a sine theta. This simplifies to cosine squared theta plus sine squared theta. And since the denominators are now common, I can write it as a single fraction that says cosine theta times sine theta. It's important that we don't forget that this expression just represents the numerator of my fraction. My denominator was 1 over cosine times 1 over sine, which simplifies to 1 over cosine sine. Now there are two things I'd like to do next, but I want to utilize one strategy at a time. The next strategy we're going to employ is the Pythagorean identity. Anytime you're looking at an expression with a sine squared or a cosine squared or a secant squared or a tangent squared, anything squared, you want to consider the possibility of replacing it with a Pythagorean identity. Cosine squared plus sine squared is equal to 1. That leaves me with 1 over cosine theta sine theta over 1 over cosine theta sine theta. From here, you may already see how this is going to simplify, but we just did in the last problem that fraction division is multiplying by a reciprocal, so let's employ that. Multiply by the reciprocal. And you can see that the cosine theta sine theta will cancel, meaning that this expression simplifies to be 1. Can't really get any more simple than that. Cotangent theta plus tangent theta over secant theta cosecant theta, the original expression, is equal to 1. Thanks for watching this segment of Objective 5 Fundamental Identities. Here's a summary of the strategies that we introduced in this segment of the video. I would take a screenshot or write down these strategies since we'll need them later on when we verify trig identities in more complex expressions and equations. In the next video segment, we're going to be using the fundamental identities to evaluate expressions without drawing a triangle and solving a triangle.